Hey everyone. I got the speaker working this time. Let me know if it's too loud or not loud enough. Let me wait for a few people to join. Okay. Okay, I think everything is set up. Okay, there we go. Now everything's actually set up. So today we're going to be trying. The motivation behind this is this loads. Computer is a little slow. I want to solve this question because we have a giveaway, not a giveaway, like a contest. If you solve this and post about it, you could win one of our pairs of shoes or shirts. I think we spoke about this last time. So I guess the ideal thing you would build here, because you're training this for MNIST, would be, a CNN. So my goal is to eventually build a CNN here, but we're going to start with just, I guess we have two CNN questions. We have a simple convolutional 2D layer, and then I think we have a full, we have a full CNN forward and back prop. So we'll start with the easy one, and we'll move from there. So drinking one of these not bad, but I don't know. Makes me feel healthy. I don't know. Not terrible. Usually I hate things with stevia. I sort of hate things with stevia, but not the worst thing ever. Okay, let's get started. I'm gonna solve everything also in the new notebook mode. Just easier to iterate through ideas and stuff, and you're able to run test cases quickly. So let's get started. In this problem, you'll need to implement a 2D convolutional layer in Python. This function will process the input matrix using specific convolutional kernel padding and stride. Given an example. So let's first understand the idea of convolution, and then we'll go see if I understand it, and then we'll go into solving it. We'll start from the beginning. So let's say we had an image. Let's give it a little more. Let's say we have a 3x3 image. Maybe shipping 4x4. Then we will have a 2x2 stride. A 2x2 convolution. Right. Let me just make sure. Let's say we have padding, stride. So let's understand these concepts first. The kernel, the padding, and the stride. So theoretically here we are given input matrix, a kernel, padding, and stride. So maybe the easiest with a 4x4. Yeah, we'll make this a 4x4. Let's take this. I know, beautiful matrix. There we go. We'll do a 4x4, and we'll do a 2x2 kernel. 2x2. 2 by 2 kernel, which basically means, sure, we will look at 2 by 2. So now we will look at these values, and I guess let me add in. So you theoretically have numbers here. So let's see, you have the number 2. And these numbers, I guess this is a black and white image. So theoretically in black and white images, you have from 0 to 2. It's from 0 to 255, which is, I think, 0 being white and 255 being black, and the intensity is between there. And yeah, I think that's, so here we could have 100, here we can have 7. So basically, convolution, I'm getting very confused. For instance, I was about to do max pooling instead of convolution. I was be like, and then you just take the max of these, and that's max pooling, which maybe we'll go over that question as well. Let me go to the learn section quickly. So invert kernel padding. This learn section's not the best. Oh. Let's see. So we get input matrix, a kernel, padding, and stride. Okay. And then I could just do this. Let's see. I guess let's read this quickly. A nested loop iterates. That's crazy. I didn't even realize I didn't know this. Well, I'm just like, oh yeah, this is how the stride works, this is how the kernel works, but I don't actually. Huh. Interesting. I could have sworn I knew how convolutions work, but either I'm not remembering or I just don't know it. Let's read this. A nested loop iterates over each position of the kernel. Okay, so yeah, so we basically go here. So let's assume we have a stride of 2. Then we go here to the next 2 because you went over 1. This would be a stride of 1. This would be a stride of 2. And then once you finish this, you go to the next part, and then there. So this can be 4 total operations. Padding is if you want to put basically a bunch of zeros around the border. So theoretically, padding would be this, and it'd be a bunch of zeros. So it'd be, I mean, that's 0 padding. I'm sure there's, I wonder if there's any point of doing any other kind of padding. And so on. So that's padding. So this be a padding layer of 1. We will say we don't need padding right now. We're just looking at the base case. Okay. At each position, let's keep dying on me. Okay, so input matrix. Oh, no. At each position, a region of the input matrix matches the size of the kernel is selected. Oh, okay. I'm starting to remember this. Okay, so there's green. is usually a matrix of itself with specific values. So you could have like 0.5, 0.2. Let's make these easy. 0.333, 0.5, and 0. So this is the convolutional weights. It's how much, I guess, to look at each pixel. And you'd basically take this, I guess multiply it. If it's element-wise multiplication, or is it a dot product of this and this? It's okay, but it's starting to come back to me a little bit. Okay. Okay, element-wise multiplication between the kernel and input region is performed, followed by sum. Huh. This value is then stored in the corresponding position of the output matrix. Okay, so let's see if we get this. So theoretically we have this. It's going to be this. I'm trying to make this look nice, but okay, so we basically have this matrix, which is the kernel. Okay, and we have our actual image. And we'll basically take the kernel and we'll go over this. So let's just do the first iteration. So we would take 2 times 0.5 plus 0.3 times 0.33333 plus 0.5 times 100 plus 7 times 0. So this would be the operation, and we would end up getting 1, 1, and 50, so 52. So we get 52. And that value would go into our new matrix. It would go into the first value. I mean, because this is a 4x4 and we're doing 2x2 strides, this would be 1, 2, 3, 4. So we'd end up with a 2x2 matrix at the end. I'm trying to think. Okay. Do we need to know the output matrix before we compute everything? I guess it'd be ideal. Then we can get the output height and output width. I think we're given. Let's see what we're given. Input matrix, kernel, padding, stride, input height, kernel height. Okay, so let's get output height and output height. Let's do one at a time. Output height, okay. Output height is computed as input height input height what does a comma mean? I'm very confused by the comma here. Okay. Let's continue. Should be. Maybe we'll work this out. I'm trying to understand what they mean by comma without actually looking it up. So we have this. Okay, so we have input height, in our case is a 4x4, we have no padding, so that's 0, and we have a kernel height of 2, and we have a stride of 2. So it'd be something like 4, comma, minus 4. So 0 divided by the stride is 2 plus 1, so it's saying the output height is, but that's not right. Oh, minus 2. I'm an idiot. Okay. Because the size of the image was 4, the size of the kernel was 2. So by comma, so this would be 2 divided by stride, which you said was 2, plus 1, which equals 2. So by comma, I think they just meant plus. Okay, not bad. So we have input height plus, just go padding, minus kernel output height, output width, pretty much the same thing. Oh wait, I need to, no, I just stopped here. So it's this divided by stride, and then all of this plus 1. Let's see. So instead of input height, we have input width, and kernel width. Just print this. Print output height, comma, output let's run it on you know what I meant? Hardest part about programming is spelling. I mean, probably not, but for me, it's pretty bad. Output matrix is not defined. Just return 0, I don't care. I just want to see, where am I? Yeah, here I am. So 4x4, this is a 4x4, this is the expected output, so I know it's a 4x4. Here we're looking for a 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6 by 6. Okay, let's see. Unexpected indent. Yeah, I need to fix this an issue with the notebook mode currently. The indentations seem to be wrong. Yeah, a little bit messed up. Oh, also this should be commented. Okay. So we know we were doing something wrong with our shaping because we should be 1, 2, 3, 4. Oh, it should be 4x4. So what was our input? So assuming this should be the I think this is the expected. I don't know what this is. It's not helpful. That's just confusing. Do we always round up? I guess this is how much. I'm assuming we always round up. So if I just did. Pretty sure int always rounds up, even if it's like 1.2 would go to 2. Could be wrong, but so I don't know why I'm. No, it does not always. Was it floor? No, there's a nice. I think you could do this. You cannot do. Is that not? 2 divided by 5. 6 divided by 5. Is it? What is this? Just. What is it? NumPy ceiling? No, not ceiling, floor. NP.floor. Okay. Where were we? I'm wondering if I'm doing something wrong, because I feel like my calculation of this is pretty spot on. Am I missing something? Let's see, we have a 6 by 6, and we have this type of kernel, and we have a 2 padding, 2 stride, so it goes here. This goes here, gets these 4, goes here, gets these. Is there padding? 2 by 2 padding. Yeah, so there should be a 0 here because there's 2, is it 2 by 2? Because we're adding like a buffer of 2, so the first things around should always be 0 like this. So we are not doing something correct. Probably should just look up the actual formula for the output height. Definitely not that. Okay. Yeah, definitely not that. Because the thing that's messing with me is this comma. Am I doing the... Oh, I also need to add that in. You don't have the hints here, which I do like. Let's go here. I also should go back and forth. Should you be able to... maybe you should be able to get a hint without running your solution. Padding formula. The formula should account for padding on both sides of the input. Currently only accounting for padding on one side. should be 2 times padding. Let it say that here. Let's see if that's right first, and then we'll... Oh. Now I'm curious if the solution is wrong. Let's copy this. Just fine. Most of these need to be... Yeah, I need to work on this because no. Where is it? Yeah, the stupid indentation errors. Output height. It's just, you can't even. Okay. Okay. There we go. Hold on. You gotta take this phone call. I'll be right back. What's up? Yeah. The landlord wants him to do it. Doesn't want him to do it. Okay. Sorry about that. I know that was a little bit of time. Let's get back into it. What was the issue? Yeah. This one is fine. I mean, all annoying, but fine. Print. This, that's correct, 4x4. And this is also 4x4. Okay. I wonder how long I left for. Sorry about that, guys. No, we're working on something cool. We'll get into it later. I just saw the first iteration of the design. I'm just thinking about that. Let's get back into actually solving this question. So we got 4x4, 4x4. So we got the input and output height. Nice. With that, probably want zeros for the output height, and we'll like fill it in with the actual information output. And okay, and we'll call this output. We had a cell here. Oh, that also needs to be fixed up. I'm assuming it just adds it to the bottom. Yeah, just add it on. So if I did a 3x3, I'm pretty sure this would be. Yeah, excuse me, 3x3 of zeros. That's what I wanted. Just making sure that was right. Okay. So now we have the input matrix, we have the kernel, and we have padding in stride. Pretty sure there's a. Let's call this A. Can I do ones? Yeah, let's call this A. Pretty sure there's a np dot padding. Pad. What's that called? Pad width. Hey, was I right? Is there a thing called pad? A is not defined. Oh, okay, cool. So we have input matrix. Oh, maybe that was the issue above. Maybe like why it wasn't working, why this formula wasn't working. I probably should apply the padding. Oh, yeah. Implement the padding first, and then I guess this also works. Input matrix equals np dot pad output. Okay. Pad that output. Okay, so now we have, no, what am I doing? So that's the current matrix with any padding. If padding equals 0, does that, okay, it's the same thing, cool. This is so messy. Okay, so we have a new input matrix with the padding. Now we have to do a stride. No, now we need to do, we need to, I guess, get little chunks. I wonder if we need to get little chunks. Right now what I'm thinking is, instead of, I wonder if this would be more efficient or not. Instead of taking this and putting it here, here, and here, and here, I'm saying iterating through this, take this, do it here, like a for loop basically. There probably is a more efficient way to do this process. I'm thinking if I copy the kernel as the size of this and then just multiply them, then I'm using up a lot of space. Yeah, let's just do the for loops. Maybe we'll look into a, there has to be a better way than for loops. Whatever. For I in, we'll start with this and maybe we'll come back to this later. For I in range, output height, no. Input height. Should have done it the other way. I'm gonna have to do this, shape 0. Okay, so this, and for J in, this. Okay, so through those things, so we get each value. I guess we would want it in both. What is a stride? Stride is an integer. I'm assuming it's, okay, it's a square thing. So we can go 0 till there, 0 till there by stride. By stride. Okay. Okay. Are we given a kernel? We are given a kernel. So this would be, let's call it M for the matrix. We have input matrix currently, but we only want a subset of that. We only want it from till I. No, that's not right. Let's play around with this. We want it, theoretically, if it's a 2 by 2, we would want from 0 to 2, and then from 0 to 2 as well. No. Is it a comma? It is a comma. Okay. And then the next one we would want from 2 to 4. Okay, so this is... Did I do that right? Till there. Sort of. Did that right? Where was I? This would be I to I plus stride. Okay. So each time we do that, we would move the convolution. Each time we would get different elements. We would get this element, and this element, and this element, and then this element. And then we're taking m times kernel. And this will be... Oh, this would theoretically go into output. Do I need a count? There's definitely a lot easier way to do this. But we're starting with the most simple. I mean, most logically simple. Yeah, let me share the link. Someone just asked for the link. Let me throw it on the chat. Probably should include that in general. I think I shared it. Really, like the fact that the comment, like I see someone's comment on my phone where I'm looking at the chat, but then I don't see my new message there or his message on my computer. I don't know. I feel like it's... I'll do it from here to make sure. Question 41. Just in case, because... Or no. I don't know, the chat on X is... It's always wonky. Always giving me issues. Let's see if I just completely reopen the app. Okay, yeah. That works. Sorry about that. There we go. Yeah, so if you guys want to follow along, use that link, try to solve the question along with me. Or do it faster than me, or better. I'll be amazed if this works, even though I guess I think it will work. And then we theoretically put out the output. And that, let's see if this even... which line it's on? Not really. Cannot access local variable input matrix where it is not associated with a value. Are we given? Again, guys, spelling. Very important. I'm just terrible at it. Are you still upset about something? Input matrix, input matrix, input matrix. No, I don't see what's wrong. Oh. God damn it, spelling. Oh, we're missing the width. So this should be, what is it, padding? Padding. We should, yeah, also we gotta improve the errors because this doesn't help me at all. Cannot be broadcast together with shape. I'm assuming it's the time. It's this. I'm assuming it's this. It's print. It's also print. The old way of debugging. Just print statements. Run this. Run this. Okay. I should have made my print statements a little nicer. Let's call this. Sorry. This is still pretty ugly, but at least we could sort of see what's going on. Okay, so M is that. K is that. M is this. K is that. Okay. So we're getting the wrong M. Theoretically, what would this be? This would be 0 and 0 plus stride, which in our case is 2, so this should be. This should be. Oh, I missed a J. Will this work? So we get our first elements, and that's not really going to move so much, but then the J moves a little faster, so the J. Yeah, that should work. Still having an issue with that. Let's see. This is what I would imagine it would be doing. Where were we? So we know what M is. So we're only getting the 1. Theoretically, we should be getting 1, 2, at least. And the 6, 7. Let's see. I plus stride. This should be going from 0 to 2, and this should be going from 0 to 2 as well. similar to this. But it is not. Let's take input matrix. Let's take, fine, do this input matrix. Not defined. We definitely need to work on, oh, that might be an issue. It just, but it is defined. Oh, is it not storing it unless the full cell passes? Which is okay. Darn it. No. Default? Okay. Okay, that's... Tell me it's not defined anymore? Okay. But I want to do this. I don't understand. Okay, whatever. Okay, for I in find range input matrix dot shape 0 by 2. Because the stride determines... Oh, I guess the kernel size we're looking for more than the stride. Stride is how much we move it. The kernel size... Let me see. Let me see if this actually works. Kernel height. Kernel width. So we want from 0 till kernel height, kernel width, but we want those going by, okay. Might have been the issue. Okay, I get that input. Okay, now we're at least we're getting M is a 2 by 2 matrix, K is also a 2 by 2 matrix. What's it complaining about now? Complaining index is out of bounds, axis 0. Five, 10. So let's just walk through this process and see what it's doing. So it's getting 1, 2, 6, 7, which is correct. Then it should be getting 3, 4, 8, 9. Is there any padding here? Padding is 0. Okay, so I'm assuming, oh, we're getting to the end and it's breaking. Because we're going 2, 2, Let's read through this and see. Because I guess we're getting to the end, and then instead of there, like it doesn't go evenly into it. Yeah, it doesn't go evenly into it, so what do we do? I think I'm pretty close. Oh wait. Just submit from here. Oh, please run the cell. Scroll down to the bottom, we will have... I mean, I know I'm not getting this right, because we weren't passing the test cases, but I want to run the get hint. Let's see if... Because I'm confused what you do when there's not enough space. Because right now we don't have enough space for the next movement. 2 unit padding, implementation is incorrect. I don't think this is true. I think the padding is fine. No, I mean, that is an issue. But I don't think that's what it's complaining about right now. Let's count as the first element. I think I is... This would be 0, this would be 1, and theoretically... So first it should be 0, 0. Then it should be 0, 1, and then it should be 1, 0, and then it should be 1, 1. Trying to think, so you can make this 0 and 0. That doesn't seem right. If I use I or J, it gets 0, then it's 2, so it'll be out of range. Let me just... this is bad naming convention, don't do this. Just append the correct thing, and then we'll... So we could reshape it. I guess we could reshape it, but right now let's just... let's output hold. I do need this. Just gonna delete it, and I was like, oh wait, that is... Oh, that ran? Oh, that ran. But then what happens... And what happens in this case? Where's my code? I know this is wrong. Let's submit it though. Unless I need to remove the print statements. Also, M is this. I want M. Okay, hold on. Yeah, I'm just screaming. You got a good nap?
Wow. Only nap for about 20 minutes.
So you feel a little bit, yeah, but just be a little.
I slept for like 2 minutes, but yeah.
At least I got that a little.
Yeah.
Okay. Full data pen M times the kernel. Yeah, but I'm very confused. Oh. I mean, no, wait, I'm doing. Not paying attention. It's the sum. Be sure. Followed by summing the result to produce a single value. 16, 21, 26, 31. Oh, nice, we're doing it right. That probably was worse than it needed to be. Hold NP array. Reshape. Output height. Output, I don't know why. Okay. The reset, I meant reshape. Oh. Not reshape. So it's 25. Okay. But we're getting close. So the first row was right. Then this is all wrong. So obviously not updating things correctly. 35, 41. I'm assuming I'm getting these, I'm getting these. But we're not, then we're probably doing oh, no. We're probably doing this with these two instead of these two. Let's see if that's actually what's happening. So we have this for I and I kernel height. I feel like I'm not talking so much this stream. I feel like I'm just busy working on this. I hope it's enjoyable to some of you guys. I was hoping this wouldn't take so long. I feel like this question didn't. I mean, it takes however long it takes. I mean, I guess it's the learning process. You know, you bang your head against the wall for a while and then you understand something. It's very easy for me to. There's a really good book, which I try to implement for myself, and I feel like it is cheesy, but the growth mindset. And it talks about how like there's the fixed mindset and the growth mindset, and the main difference is for a growth mindset, you know that you have to bang your head against the keyboard, and struggling is how you learn. Versus a fixed mindset is basically you think, oh, I'm so smart, And if something challenges me, then then makes me feel dumb. So I don't go towards things that challenge me. I go towards things that easy questions. I do things that I know how to do. I'm like, oh, look how smart I am. I solved this so quickly. And you never do anything that tests yourself, and you never really grow. I think everyone is a little bit of both. It's easy to get caught up in the I should know this. This should be quick. This should take me 10 minutes, and it doesn't. Then you get nervous and upset, and it's just important to remember, you know, learning is like you're learning if you don't understand something. If you understand something, something's easy, and it takes 2 minutes. You didn't learn anything. The more you struggle, the more you learn. It's like the more, yeah, it's a nice way of letting you know you actually are learning something you don't know versus learning something you do know. I feel like it's taken me a while just to, I don't know. The journey of self studying is always fun. I'd love to hear other people's self studying journeys because I feel like everyone in machine learning and data science, we're all in the same boat. We all have to self study, and uh, yeah, two big questions I always hit were how do I know something, and how can I show off I know something. I mean, DeepML, I trying to answer those two things with, this is how you know something if you could actually implement it. Like I thought I knew how a convolutional layer worked. I was like, yeah, it's simple, easy, whatever. You get down to the bare bones of it, and this gaps in my knowledge, and I'm learning that. Um, but yeah. And then the second part, I feel like we have collections for, which I don't want to touch anything right now. I want to solve this question. Uh, where you could get like a little certificate that you could put on your LinkedIn or something like that, just showing you know a specific topic. Okay, back to solving this. Let's see, I'm pretty sure the bug is having to do with this. So let's print out M. So we're doing 1, 2, okay, 5, 10. Then we're going 6, 7. Yeah, I was right. But how do we fix it? Because I guess we're going here and here, and then so I guess we got to go 2 layers down. But this isn't updating. Do I need I? Is it just J? Let's see, 1, 2, 7, 6. Yeah. She's gone. Let's see. So after the 5, 10 stuff, after the 5, 10. Okay. There. 1, 2, 6, 7 should be the first one. 7, 8. Where are you getting? Oh, 7, 8, 13. Okay. Yeah, that was wrong. So this is I. Because we want those to move. And for our next iteration, because for the next input we need the did I not? I did. Close the door. Sorry. Yeah, that door always closes heavy. It always sounds like I'm slamming the door. Let's see. Kernel height plus 2. let's rerun this. Let me see what's going on. I know what's going on. Then we're just going to let's fix this. Fix the cells. Okay. But we basically want find range length. I think I'd get used to all these loop-de-loops, but I always find myself, yeah, I always find myself making mistakes here. From I to I plus 4, and we want to do j till j plus 4. Okay. Invalid syntax. Why invalid syntax? Why are you outputting anything? Yeah, I need to fix up this because this is a bug. This is just running the solution, it seems like. Not running this. Gotta use the competitor. I don't really think we're that much of a competition for collab, but let's just open this up. I don't know what's here. Oh, it was invalid syntax though. Why though? Ugh, it's this. NumPy is not defined. You know. Okay. Oh wait, shred was 2. Okay. So 1, 2, 3, 4, yeah. 5, 10, yeah. Then it's 11, 12, 16, 17. Yeah, is that not what I did? I guess I'm doing something stupid somewhere. Oh. 11, 12, 16, 17, 13, 14. Oh, okay. So just getting messed up with the stride a little. That makes sense. Maybe. Let's see. It should be 2, 2, these two, these two, these two, and then the last should be. Yeah, that makes sense. So let me. Definitely getting closer. Here we go. Some of these are wrong. Not even close. Oh, we're just skipping. We're skipping it altogether, aren't we? Yeah. Okay, but at least we know where the issue is coming from, sort of. I gotta edit this, sort of. Okay, so the first round, Strata theoretically, value of 2, right? Yeah, Strata is 2, so go 0 till here, and 0 to here. And the next one would be 0 to here, still correct. And here would be, theoretically go strides of 2, so there should be, be 2 by 1. Let me just print this one out, print it is defined. Okay, so it would be 0, 2, then 4. In my input matrix, if I go 2 by 2 by 2, 0 by, I go 2. So if I want the bottom left, it would be 0 by 2, comma. No, this would be 2 by 4, and 0 by 2. That should give me 11 by 12. Make sure that's what I want. And this is really the only way to get better at this stuff. Okay. I mean, it's not the funnest thing in the world doing these, because I know it's just a small little detail that I'm missing. But it's also how you get better, and I need to, I mean, I feel like it's just me reminding myself this so I don't lose it. Just so I don't oh my god, I'm doing terribly. 11 by 12, okay. So there needs to be 2 by 4. kernel is size. I guess what would this be next? It would be because this would be 2 plus that. Okay. Oh, probably should have just done the problem breakdown. Let's see if we have one. Yeah, probably should use the breakdown, but let's. I understand my current implementation is wrong. Where is it? Where am I messing up? Padding implementation. Okay, I'm doing that right. Loop boundaries. That's helpful. Okay, let's see. Okay. So right now we're getting 1, 2, okay, till 5, 10, correct. Then we're going 6, 7, 11, 12, which is incorrect. So we need the stride to go down as well. But it doesn't feel like this. I guess what happens? So then we're in this case scenario. We're at 2. What is the kernel size? I think the kernel size is 2. Oh, stride is 1. I don't think that makes a difference, but it sort of does. Stride is 1, so theoretically it should be 1, 2, then damn. It should be taking this box and then only moving over 1. So what we're doing is 1, 2. Let's see, 1, 2. It should be the next should be 2, 3, 7, 8. 2, 3, 7, 8. Oh, why is it in? Yeah, 2, 3, 7, 8. It's correct. What size is the kernel? Yeah, okay, it's a 2 by 2. So we do this, we do this, we do this, then we go down 1. We do this, we do this, we do this. Okay. So I was just not. Okay. Not reshape size 25. That makes sense. We should have 16, not 25. So I guess the issue we're running into. Let's print our current. Let's print our hold value. Okay, this makes a lot more sense. Damn. Can't believe I made. Okay, I understand. Okay, 16, 21, 26, 31. Correct. 35. Wrong. 41. Correct. 56 is correct. 60 is wrong. So every fifth one. 66, 71, 81. Correct. Then 91 to 106. So basically, if okay, I just want to get this right. This won't be the neatest thing. If m dot if m dot shape equals kernel dot shape okay. I want to look at this solution. Should I mean, let's run this, get this right, and then we'll look at the solution, because nice. Need more test cases for this. But fudge this question. How? I understand. How much easier could have this been? Okay. That's just. Okay, it could have been a little easier. Oh. This multiply times stride thing. Okay, whatever. Okay. We did not get nearly as far as I thought we would get, but it's a start. Next time, so our eventual goal is to solve this question, which is basically implement, a neural network of any kind you want to train MNIST. We want to do this, but we want to do it with a CNN instead of regular neural net. Stage 1 is complete. I thought stage 1 would be a little faster. Stage 2 is probably going to hurt even more. Is going to be implementing CNN with backpropagation. And I feel like once we are able to do this and we're able to do the other one, I think we'll be able to, solve that lab question with a CNN, hopefully get the top spot. I feel like if I can make a CNN, we should hopefully get a top spot. I mean, should I add right now we have a competition running where if you basically, I probably could solve the lab. You need to get 85 or more accuracy, and then you post it on X or LinkedIn or whatever, and you get a chance to win either a t-shirt or shoes. But my goal is to make the CNN, and I don't know if I should consider myself in the raffle or not. I probably won't, because if I win, what am I going to do? I feel like people will be like, oh, you cheated, so not going to do that. But thank you guys for joining. Sorry. I'm not sorry. You decided to watch this. Have a good day.